In this podcast, we're going to be looking at a couple of data sets that explore multiple dependent variables. The ANOVA models are very useful, but one of their limitations is that they can only assess one dependent variable at a time. And the MANOVA is an extension of the ANOVA when there are several dependent variables. And it's helpful because it reduces the error variance which mounts up because researchers may be tempted to run multiple ANOVAs on separate dependent variables, and this doesn't take into consideration that there would be relationships between all of the variables in the data set. So the MANOVA extends the capabilities of ANOVA, and it has this added advantage that it helps reduce the chance of a type 1 error, which is a false positive, and a type 2 error, which is a false negative. We're trying to determine through student ratings of laughability and stupidity in the act, which one of these three actors was higher on laughability and higher on stupidity. So we're going to use the general linear model, and it's multivariate because we've got more than one dependent variable. And our fixed factors are the favourite actors, and the dependent variables are the laugh index and the stupidity index. The contrast button opens up a dialog box for specifying one of several standard contrasts for the independent variables in the analysis. We won't be running any contrasts within this analysis, but it's useful to look at if you were intending to do so. Rather, what we are interested in is carrying out post hoc analyses tests. And they tend to be used in this analysis. And the ones that are most popular to use are usually recommended to be the R, EGWQ, and Games-Howell. It's also possible under the Options button to add a few additional analyses. And here we're going to select Descriptive Statistics, Residual Matrices, and Tests of Homogeneity. And now we're ready to examine the output. The first thing that we can do is make a rough assumption about popularity by looking at the means, and we can see here that Curly makes people laugh more, and we can also see that Curly behaves in a more stupid way than the other of the Three Stooges. The next thing that we're interested in is the Box test of the equality of covariance matrices, and this statistic should be non-significant. And we can see here that and what this means is the covariance matrices within this model are roughly equal as assumed. The test that's generated is Bartlett's test, but this is not actually relevant to this particular analysis, and it really is only useful in univariate repeated measures design. So MANOVA doesn't really require that we look at that particular analysis. In the next table, we see that SPSS has provided us with the four main multivariate test statistics, and their values correspond to the extent to which the model is significant. It tells us very little, however, about which group is significant from others. Then we have Levene's test of equality for error variances, and again this should be a non-significant result for all dependent variables if the assumption of homogeneity of variance has been met, and we can see here again that it has. And the next table looks at the differences between each of the individual actors and whether they're significantly different from one another in terms of the laugh index and their stupidity index, and you can see that stupidity is the one variable which seems to be statistically significant. We can therefore conclude that there is statistical differences between each of the three actors and their stupidity index. So the multiple comparisons table on the post hoc test allows us to drill down in more detail to determine where the actual statistical differences occur. So here we've got the laugh index and the stupidity index, and we've got each of the individuals relative to one another. And there is some repetition within these, so you do need to be careful that you don't interpret something twice. Curly and Larry have no statistical difference between one another in terms of how much they make students laugh. Neither is there a difference between Curly and Mo, and we can tell this because these values are greater than 0.05. Again, let's have a look at Larry and Curly. Do you think that this is a statistical difference or not? And the same with Larry and Mo. And what you want to do then is you want to look down this list to determine where the very small values are. So here we can see that between Curly and Larry, there's a very small figure, which is smaller than 0.05. And that would suggest that the main difference in this is between Larry and Curly in terms of how stupidly they behave and how they differ from one another. The next data set that we're going to look at examines personality differences across different groups across the world. And you can see here that we've got European Americans, Asian internationals, and Asian Americans. And we're looking at differences relative to their big five personality variables. So we're going to run the same analysis using the general linear model multivariate test option. We will put our 5 variables that are dependent personality variables into the dependent variables box, and we'll transfer our different groups here. So we now need to decide what additional tests we want to do. We don't need any comparisons at this. And under options, we like to display some descriptive statistics. So once again, we can now explore that we have the means here between each of the groups on their personality factors. You can see that in terms of most of the groups, there doesn't seem to be much of a difference in terms of the mean on neuroticism, extroversion. European Americans seem to be more extrovert. Asian Americans more open to experience. On agreeableness, Asian Americans are more agreeable, and there's very little difference between the groups in conscientiousness. Our 4 main tests of statistical significance appear to be functioning and statistically significant, and then we go down and we start to look at the group differences in this model. And we can see here that there are statistically significant group differences. So we go down now and we look at our tests of between subjects effects. And we can see under group that there are indeed some statistical differences between the different groups on the basis of extroversion, openness, and agreeableness that would be of interest. These p-values are larger than 0.05 and therefore they are not statistically significant. What we don't know again is who is different from whom, and to be able to do that we've got to go down and explore our post hoc comparisons, and here we can start to drill down where the actual differences are using the significance table here. So you should now spend a little bit of time looking at these differences and trying to identify which groups of individuals differ from each other.